work. We are going to talk about the image model, how to model a digital image in this class. Now, what does the word photography stands for? Can anyone tell me? So if it's possible for anyone, many of you do photography on a very regular basis. In fact, present day world, we everyone is a photographer.
So the word photo stands for light.
The word photo stands for light, yes.
And
So one two word here. So one is the photo, another one is graphy. Now what does the graphy mean? Graphy stands for.
creation.
Yeah, I mean you are in the right direction. Graphy means something which is graphically shown. Graph plotting we all know. Graph plotting is nothing but a two-dimensional presentation, correct?
Yes, sir.
So here also it's a it's a graphy. So I would say, in a very simple way, I would say that all you are doing is, in photography you are doing using light to make a graph or make a two-dimensional object, make a two-dimensional representation. The most easy word I can get is something called as painting. You are actually painting with light. Just that your medium could be something different. It could be a film, it could be a CCD. Sensors are different, but basic approach is you are using light to paint an image. Okay, I hope you will all agree with me. If there is no light, you know that the photography is not possible or image making is not possible. So just think about it. Whenever your camera, you raise your mobile camera and take an image, all you are doing is you are capturing the light which has been reflected from the various objects. Okay, and then what you need, one more thing, you need a source of light. Like if it's dark, you won't be able to achieve photography. You all know that. Many a times you try to take your selfies in the dark and it's very difficult, very challenging. Although the present day DIP allows that also to happen, even with a very small amount of light, but zero light means it is not possible. So basically, there are two aspects here, two physical aspects. One is the light which is available, and one is how much it is reflected from various objects. Okay, so which color light a red object reflects? Can you tell me? If an object looks red, which color or which wavelength of the light does it reflect?
Red.
Does it reflect red or does it absorb red?
It
Reflects red.
absorbs everything else other than red.
Yeah, it reflects red color and it absorbs every other color. Remember that. Same way happens for any other color. Suppose if an object looks yellow, it reflects the yellow wavelength, absorbs everything else. What happens to an object which looks black?
Absorbs everything. Absorbs every color.
Yeah, black absorbs all the color. And what happens to an object which looks white?
Reflects every color.
Reflects everything. So now as I am saying that we need to create a mathematical model. So the reflection from various objects is modeled in terms of reflectance. Okay. Reflectance is typically defined as amount of light energy amount of light energy reflected divided by amount of light energy incident. This is the way you define the reflectance. I can write it with a small r. Okay. So this becomes one of the parameters. What is the maximum value that reflectance can have?
1
When will it be 1?
For white
like
color.
light.
It will be 1 if all the energy that is incident is reflected. Okay. Yeah, that is
Yeah.
when it is a white object. So reflectance R is equal to 1 for a perfectly white object or very shining object, silver colored object. Minimum value for R will be 0 for a black dark object. Correct?
Yes.
Isn't it? Now let's go to the, so this reflectance can be modeled, reflection can be modeled in terms of reflectance. Now comes to the question of the source of light. How can we model the source of light? Now the source of light vary. Sources of light vary. You can have a very bright source of light like sun. Can you tell me a very dim source of light? Maybe moonlight. Correct?
Yes.
Any other? I mean, if light is there, normally candlelight is also there. Would it be dimmer than the moonlight or not? Suppose in your room a candle is lit. Would the light be dimmer compared to moonlight or not? That's a very subjective question. You need to have some sort of judgment. The sun is one. The other artificial sources are other one. The next is reflected light, like light in a room. I would call it daylight from window. So from your windows you may get daylights. These are all the examples. Now you can see that the amount of light varies. Typically we can define something called as illumination. Or amount of light available. Now, illumination is typically defined in terms of intensity. How much intensity is available? Available intensity, I would call it illumination. And it has a huge variance from here to here. For example, for sun in day-to-day life, it can run up to 1 lakh to 10 lakh, depending upon the cloud conditions and other things. On a bright sunny day, you can easily get a 10, this figure running in terms of 10 lakhs. 1, 2, 3, this, and one more zero, I guess. While for a moonlight, it can become 0.01. It could be so low. Okay. So illumination becomes one of the important parameters. May I represent it by I? So I have got two parameters, amount of light available and amount of light reflected. So for example, if you have a camera system, this is my block camera and this is an object which I want to image. And here is the source of light. The source of light has an illumination I and this object has a reflectance R. So the light will come from the source onto the object and then reflected from the object to the camera. So the key question is how much light will enter the camera. I mean, before entering the camera, how much light will be available. If I is the illumination and R is the reflectance, how much light would be available to the camera? Can anyone think and tell me this part? I is the light which is incident. R is the light which is, R is the reflectance. So how much light would be reflected?
RE, incident.
Yes.
Incident minus observed.
Incident minus what? Absorbed. Well, I have not modeled absorbed light. We will not need it. We can do it in terms of incident and reflected. So it could be as simple as I times R. Can you notice this?
Yes, sir.
For example, if object has zero reflectance, very dark object, no light will be reflected. So that will give you the minimum intensity. Okay. So the camera, the light that camera receives, I may call it as L. Then L minimum could be, if the reflectance is 0, then this is going to be 0. I would say L is equal to IR. If L minimum is 0, then if R is 0, L minimum will become 0. When when will be L maximum?
Sir, R is equals to 1.
R is equal to 1. So when R is equal to 1, it is equal to illumination, correct?
Yes, sir.
Suppose light is coming from sun and you put a mirror. lot of light will be reflected. Correct? Now, the camera has a challenge. Now, listen to this part very carefully. Because this is not which is often talked always in a DIP course. Camera has a challenge. As you have seen, I value varies from a very small to a very large value. Minimum is fixed at 0, but maximum is not fixed. For example, if you are taking a photo on a moonlit night, on a very low light, your maximum is very less. While on a sunny day, if there is, say, some snow available on the scene, lot of light will be reflected by the snow, and that will give you lot of light to your camera system, because Lmax is I. Would the camera system be able to record all these lights? Say on a sunny day, this much light is available, Lmax is I. Would the camera sensor be able to record all these? What do you think? Would it be able to do it?
No.
Camera sensors. We will have to take a look into camera sensors. Now the camera sensors, the modern day camera sensors are nothing but photodiodes, and these photodiodes are arranged in a two-dimensional array, as we have discussed in the last class. I can mimic these two-dimensional arrays, camera sensors, in the form of buckets. So this is one light sensor, one photodiode, and after some distance we will have another photodiode, and after some distance we will have another photodiode, and after some distance we will have another photodiode. This is how the various camera systems are designed. Now what happens when the light is incident? How does a photodiode work? Which physics principle does it use? These are my photodiodes. 1, 2, 3, 4. This is the light which is incident. So you know that the current in the photodiode, or number of electrons liberated, is proportional to intensity of light, or which in this case I am calling as I, or to be more specific I am calling as L. Remember, what do we call this effect as?
Photoelectric.
That's right. We call it this as photoelectric effect. So if less light comes, some electrons are liberated. If the light is very poor. But if the light is very strong, that is, if you are on this side, what happens? Lot of electrons will be liberated, remember. And very soon these buckets would be full of electrons. Now once these buckets are full, you have no way to generate more electrons. Remember that. There is absolutely no way to generate more electrons once these buckets are full in a very strong light. Even if more electrons are generated in some cases, they spill over to the neighboring regions, giving everything is a mess. This entire area, 2 pixels cannot be separated, and everything will become a mess. So basically, there is an upper limit to which number of electrons can be accumulated in a bucket. There is an upper limit. Okay, do you all notice this? What will decide this upper limit? Can you tell me? This is a slight digression from the subject, but can you tell me what will decide how much maximum number of electrons, that means how much maximum light entering the camera system the sensor can handle? What will decide?
So the area under which the light falls.
Area under which uh, area under which the light falls is roughly same, like size of the sensor. There's something slightly more. You can see my analogy here. It's a bucket. How much can you store in a bucket? Which parameter does decides how much you can store in a bucket?
Sir, breakdown voltage is related to that.
Why are you making complicated? I'm asking a very simple question. How much आप एक बकेट में कितने एप्पल्स रख सकते हो, ये किस बात पे डिपेंड करता है?
Size of the bucket.
Volume.
Yes, volume or size of the bucket. Correct? So that means if you have a deeper bucket or the larger sized bucket, in this case, if you have a deeper or larger sized photodiodes, you can say, I'm coming to that part. Like you said, size of the sensor. Size of the sensors generally is fixed. For example, here, say this is my size. But then if in the sensor there are number of photodiodes. So if the photodiodes are big, if each photodiode is large, you can store lot of electrons. Am I right?
Yes, sir.
That means you can record lot of intensity. However, there is a negative. There is a negative to the very large pixel size on a given sensor. Can you think what is that negative thing? What is that negative point? What is the drawback?
So the resolution will be low, right?
Yes, you are right. Spot on. The resolution is going to be poor. You are having very less number of pixels, and therefore the image will look grainy. I'm going to talk more about resolution in the next class. So resolution is going to be poor. So on a given sensor, if you want a decent, so there is a difference between a sensor size, which is this size, or typically it is measured in terms of the diagonal line, and the pixel size. So same sensor can be 6 megapixel, and same sensors can be all 12 megapixel. So if it is of 12 megapixels, it has 12 million photodiodes on it, and in that case each photodiode will be much smaller. So if the photodiode is small, then resolution is high, no doubt, but then what is the drawback? If each pixel is very small, resolution is high. Therefore, what will be the drawback here?
The upper limit of will be lower.
That's right. Then each pixel is small in size, and in that case, your capacity will reduce by some value. You can generate less number of maximum electrons. Since this decreases, you can sense stronger lights very poorly. You understand that? So that's an engineering compromise that every camera manufacturer does. An entire marketing, quality, and everything revolves around these two compromises. That how much size you keep here and how much sensitive or how much is the capacity of each photodiode buckets. Okay, so you can now see that you have a limitations to which a camera can record L. Typically this limitation is not there on the lower side. L minimum is 0, and that is understandable. No light, nothing is recorded. The limitations or the compromises happen on the maximum side. The L max that the camera can record will depend on the size of the sensor and the size of the pixel. So even on the same sensor for a mobile phone camera, typically the sensor is 1/8 of an inch or 1/5 of an inch. Now in that sensor, if you have a 6 megapixel or 12 megapixel or 24 megapixel, that will greatly decide how much is your maximum intensity that can be recorded. So it varies from cameras to camera, it varies from system to system. So all I can say is, if I want to go ahead at this point, all I can say is, let us have a standard value L min, I would call it, which is 0. Well, I'll not write here, I'll write here, which is 0. And let's say that a camera sensor records a maximum value L max. Now remember, when I wrote small L max, it is the maximum which is available to the camera. When I'm writing capital L max, I am saying this is the maximum level that the camera would be able to record on its sensor, depending upon the size of the sensor and the size of the pixel, L max. Okay, now this will not have a definite value, it can vary from system to system, and then L will have any value in between, right? So is this clear to people who are listening? You have any question or doubt at this stage, please ask.
No, sir.
If you have any doubt or question, please ask.
No doubt, sir.
Okay, that's great. So camera system will record from L max to L min. I would basically, for our DIP purpose, I will scale L minimum to 0, and one of the easy way to scale L max is equal to 1. Now it depends on the camera system. This 1 is subject to interpretation. That so it's, in some cases the L max can be very large, in some cases the L max can be small, but whatever is the L max value, I may call it for the time being as 1. I will tell you next class. I will interpret how this one can be interpreted in a different way. But then your intensity values can range from 0 to 1. Here it is, you can see that these are the recorded values. Your scene will look very bright, and here the scene will look very dark. So I will just share an image with you people. Can you see the image on the screen?
Yes, sir.
Yes, sir.
How does it look like? Where is the zero of recorded intensity in this image?
Rightmost.
Rightmost side. You can see that this rightmost is the zero of the recorded intensity, and this is a box, and the leftmost is the one of the recorded intensity, or maximum of the recorded intensity. You can use a PowerPoint or some other software to create this kind of image where a gradient, a value, here it is 1, here it is 0. As you go from here to here, the illumination will change. Is this clear to everyone? So it's been little complicated by now so far, but let me just revise quickly before I don't think I would be able to talk ahead from this point, because the next point is talking how to digitize and how to sample this kind of situation. But instead of going into that, let us look into this. So what we spoke of today was light painting or writing with light. Photography is, that is how you define photography, if there is a definition to the photography. Typically, the light that comes from the camera system, which is available to the camera system, has two aspects. One is the source of light, other one is the reflected from various objects. So light comes from the source. If there is no source, there will not be any light, there would not be any recording. The light which is reflected from the object is defined as the amount of light reflected upon amount of light incident. We have seen that the reflectance coefficient R is 1 for a very white or a bright object, and it is 0 for a very dark object. Source of light can vary intensity from very bright to very dark. In absolute terms, we call it as illumination I. And then how much light is available to a camera system? So straightforward, if S is the light if I is the illumination available, R is the reflectance, then you have I into R available to it. For example, if the object has 0 reflectance, then the light which is available to the system will be 0, and obviously no light will be available. And if the reflectance is very high for a mirror or for a white silver surface, then the amount of light available is very high. So L max and L0. Then we discussed that it is not possible for a camera system to record all these L max. There are issues with L min also. Has anyone any idea about what issues can happen with L min, minimum light? Because remember, I just said L min is 0 and that's it, like minimum is 0. But there are issues with minimum light recording as well in camera systems. Has anyone any idea about it? If not, then figure out. You can just do a Google search. What are the challenges in recording very low light? And you will figure out the challenges and issues there. But I'm focusing on this. I would say that L minimum is 0. L maximum depends on the size of the photodiode used in the camera sensors. Depending upon the number, if numbers is large, diodes are smaller. If numbers are smaller, diodes are larger. It affects resolution, it affects further post-processing, it affects cost, it affects marketing. So if you go to market and the salesman says this is 12 megapixel and this is 20 megapixel, perhaps you will always think that, oh, 20 megapixel, that's great camera because it has a larger resolution. So that's a marketing tool also. Whether would it be great in reality or not, you don't know, because each sensor is small and the maximum light that it can sense is lesser than a 12 mega, should be lesser than a 12 megapixel camera. But it's a marketing tool or marketing gimmick also. So L minimum and L maximum, they vary for our DIP sake, or even for the when the camera system records. They generally define L min as 0, but L max has a limit, and this L max can be equal to 1. We, for our purpose, we can right now define L max is 1. So the dark side of an image can be, say, represented by 0 intensity. Bright side of an intensity is represented by 1 intensity. So 0 and 1. And we have seen one image where this is the brightest side and this is the darkest side. So this side is 1, this side is 0. Okay, so with this we end this class officially from my side. If you have any doubts or any questions, you can ask. Thank you.